Hi, I'm following along with Paul McCorder's Raspberry Pi Pico W lessons, and he's up to 30. I'm going to be doing 36 tomorrow, and it talks about controlling the servo with MicroPython. I've been following several of Paul's courses, and we also did servos on the regular Raspberry Pi, so I was kind of familiar with that. And early on this class, I uh, jumped ahead and started working with servos. I was working on a quad walker project that kind of got sidelined for the time being, but I was able to get a lot of code for the servos and everything done. So also, I'm not the first one to jump the gun on this. Scott over here uh, had a great idea using his weather station and displaying the temperature on a servo, converting it over. And uh, he said he found a servo library online that he was using, and so he didn't necessarily get to show the math on in his code, but he was he also was looking forward to Paul doing the math for that. So that was good. And like I say, I'm looking forward to Paul doing the math, but I figured I went back to my Raspberry Pi and got the math out, and I actually decided to create a library or module. Python calls them modules out of this, a servo module of my own. Only took 18 lines of code to get it done, so I figured, let's do that, and you can make as many servos as you want and just initialize them, and then just use one function to set their position. So let's get to the code, I guess. Uh, where am I at? Thorny. Here we go. So here's your Thorny. And like I said, it's only 18 lines of code in the actual module, and we'll get to starting on this. So I do want to bring up a little graphic that I got. So servos are usually defined by their microseconds that they have. So let's bring up that little graphic that we have. So we have a period of 50 hertz, or our PWM frequency is 50 hertz, which gives you a period of 20 milliseconds. Now, for the servos, you're going from 1,000 milliseconds to 2,000 milliseconds. I guess that's on a great servo. On a little hobby servos, it's more like the range is from 500 microseconds to 2,500 microseconds. With and it's still 1,500 microseconds seems to still be at the 90 position point. So I don't know whether they're just designed a little different or cheaper or whatever it is, but that's the way it goes. But anyhow, we'll use this as our thing. So the min servo is like I say 1,000. We're only going between 1,000 and 2,000 microseconds. Like you say, that's not much of our range. Remember, with PWM, we have the range of going all the way up to 65,535 to make it, close to 100% on. But we don't need anything like that for servos, so we got to convert from microseconds into our PWM width on our things. So the way we do that is we take our microseconds and okay, so we got our units we got to be concerned with. So we got we know we got 65,535 steps in our pulse width, and we have this 20 milliseconds as the whole length of it. So, but that's in milliseconds and this is in microseconds. So we need to convert that. So 20 milliseconds is 20,000 microseconds. So to convert from microseconds to pulse width, we need to multiply by the 65,535 and then divide by the 20,000 microseconds. So show how that's done. So I'm actually getting the microseconds as a when we initialize a servo. Um, we'll talk about all the initialization in a second, but you're getting the min and the max, and then we're actually changing it into the PWM min and max down here. We're going from microsecond to PWM. So we're doing what we said, we're multiplying by 65,535 and divided by 20,000. And that gives us our PWM width is what we need. And like I said, that's only going to be on a slight end of it as out of 65,535. I think we're going to end up with like these numbers are going to be between 1,700 and 7,500 tops on that. So you know, you can do the math in your head, but you could either do this every time you set a width on that and do the slope function, but I decided that, okay, we know what our min and max is. We only need to do this one time as we initialize it and get that number. And so now we have our X1 and Y1, and then we also have our min position and our max position. So we got our X2 and X1 and X2 and X1, or however, Y1, that's right, X1 and Y1 down here. So we can plug that into our slope formula, and that gives us our slope that we need. And we'll use that down here when we set our position using our offsets to get that. So, but the thing is, when you initialize it, you only have to do these calculations one time, and you get your slope and you get your PWM min and max that we're using down here. And that's the way to do that. So let's get back to when you initialize it. Like I said, we got the servo class. Of course, we need to import the pin in PWM so that we can use it. And I got the sleep in here because down here I got some example code that when you set up a module, you can put example code down there. So that's what that's for. So when you declare a servo by calling it like S1 or servo 1 or whatever you want to call it, the only thing that you need to have to do, the self is going to become the servo 1 or whatever it is the pin number that you're going to use. That's the only thing that you have to input. These are all default values in here, but you could change them when you do that. So if you wanted to, if you found that your servos weren't working at 500, you could call them US min equals 700 or something like that. And also, I'll show you when I do my examples that we're not stuck with the 0 to 180. We can use whatever we want on that, and we'll show that when later in the code. So that's all that we got there. Like I say, we're calculating all this in our initializing and setting that up. And then the only function that we have or method that we have in here is just a set position. And the only thing we need to put in there is our position, which has to be somewhere between our min and max. And we actually do that with this line of code here. We're making sure that our number is between the min and max. And if it's outside, if it's above our above our max, we'll make it max. If it's below our min, we'll make it min. So this is kind of just a line of code that uses the min and max functions of Python to be able to set your position so that it's in bounds of whatever you want it to be. Then we're just, like I say, we're using our offsets here. We're taking our position and making sure our min and our the min of both of them. The reason you got this over here is that because that way this allows you to have, like, if you have like a negative, like I'll show you where we're doing between -1 and 1 on our code a little later, and that's why you need to have this in here. So this is our offset from our slope that we have. And then of course the only other thing you got to do is when you get your PWM of wherever your destination angle is or number is, that you can set the duty cycle and it'll get there. So down here we have just a little bit of extra code. Like I said, when you set up a module, you can do this name equals name, then it'll run this. If you're actually running this code or this file, it'll run this code. If you're calling it from another code, like we'll do a little later, this doesn't come into play at all. So here we're just actually setting up one servo, and we're setting it up on pin 16. And we're not adding any of our extra inputs to it, or attributes to it. And so it's going to be 0 to 180, and it's going to use the microseconds that we set up as default. So it's just going in. I just got a while true where it's going to go from 80 to 180 to 90 to 0, and then back over to 180 again. So we can just run that and show that it's actually working. Mm, 180, 90, 0. 180, 90, 0. And then I got where I can control Z to get out of this, so we'll get out of that. So that's what we got going on there, and if you wanted to run it right out of that, but then, like I said, remember we already got our machine and everything in here, so when we go to our regular one, we don't even have to import anything like machine or pin or PWM. We can do it here when we import our servo. Now we had time over there, that was just for the example code. And we're actually using time outside of our servo calls here. So we have to, because we're using it here, we'll have to import our sleep as well. So here I have it set up as servo 1. It's pretty much the same code, but now the min position is a -1 and the max position is 1. So 90, so 90 degrees is actually going to would be 0, but I'm actually showing that you can use fractions in here. So it's going to go from -1 to +1, and it's still going to swing the 180 degrees, but it's going to, so this would, the center position, 90 position would be 0, so 0.5 is actually going to be like a 45 degree position, and I'll show you as it's running that that's what it is. So let's see. So swinging over to -1 to +0.5 to +1, -1 plus 0.5 to 1, -1, 45 degrees is +5, 90, there you go. So that's how that works. So you can either, like I said, don't have to do any of this. You can just call your pin on it, and you got that. Or you can do this. Another thing we could do is we could leave this at 0. We could call this 0, but our default is already 0, so we can actually leave out this default altogether. But we can make our max position 100. Let me control Z out of here so we get out of that. So we can make our max position 100. So now the default was 0 for min, so now it's going to be between 0 and 100. So we can go that this is 0, and we could say the midpoint's going to be 50 now, and full around is going to be 100. So this, if you wanted like a percentage, or you wanted degrees or something like that, you could actually make it from -20 to 120. You could do that and put that in there as min and max. I think that's what Scott had on his graph there, that it was between -20 and 100 or 110. You could do whatever. But I'm just going to show you how you could do it 0, 50 to 100 if you wanted like a percentage of, say, if you needed to put a percentage value and you wanted it to swing over 100%. So we'll just run it at that. But you'll see this is going to be pretty similar to the any of the other ones, because it's going 0, 180 to 90, 0, 180 to 90. Anyhow, that's what I got for today. Like I said, pretty comfortable from Paul teaching us about servos and the Raspberry Pi, so I was able to get this done on the Pico. Looking forward to what Paul does to it, and you can look for a link to this servo library on my GitHub in the description here. Thanks for watching and have a good